Welcome to Math Challenge 552. Math Challenge for school exams, junior and senior Olympiads, university admission tests, and all competitive examinations. Now we are given a scalene triangle. You can see that the three sides are of different lengths, right? Three unequal sides, scalene triangle, and an inscribed circle. That means circle is inside. When circle is inside, we call it inscribed. So inscribed circle, and we have to find the radius of this circle. The radius of the circle inside, that is an inscribed circle, this radius would be called inradius. Inradius means the radius of the inscribed circle. So we have to find the inradius, that is the radius of the circle inside the scalene triangle. And we will do it by two different methods. We will do it by two different methods, Math Challenge 552. Now in both the methods, we said we will do it by two different methods. In both the methods, we have to find the area of the triangle. Method 1 and method 2, both will require the area of the triangle. So here the three sides are given, A equal to 50, B equal to 20, C equal to 25, and semi-perimeter, A plus B plus C whole by 2 is 30. 15 plus 20 plus 25, that is 60, divided by 2, 30. So semi-perimeter 30. Now we use Heron's formula for finding the area, square root of S into S minus A into S minus B into S minus C, and we get 150 as the area of the triangle. The area of the triangle, scalene triangle, is 150 square units. Now after this, we will show you method 1 and method 2, because in both the cases we will need area of the triangle and also this semi-perimeter. Semi-perimeter 30, area of the triangle 150, both of them we will need both in method 1 and in method 2. So semi-perimeter 30, area of the triangle 150. So the first method, we calculated area of triangle 150 and semi-perimeter 30. In the first method, we use formula in radius, that is radius of the circle inside the triangle in radius is given by area by semi-perimeter, A by S, that is 150 divided by 30, that is 5. So we get the in radius is 5 units, radius of the in circle 5 units. We are using the formula A by S, area of the triangle divided by semi-perimeter. So the radius is 5 units, 150 by 30, that is 5 units. Now we will see the second method. In the second method, we need area of the triangle and the semi-perimeter. Now draw radii from the center to each side. You can see the animation. From the center to each side, draw the radii. Now each side is a tangent, so the radius would be perpendicular to the tangent, right? You are drawing a radius from the center to each of the sides, and each of the sides of the triangle being a tangent, a radius would be perpendicular to the tangent. So the animation you can see are radii perpendicular to the tangent or perpendicular to the sides of the triangle. And also join center to each vertex of the triangle. Each vertex, see the blue dotted line, So we are drawing 3 blue dotted lines joining the center to the vertices of the triangle. Right? So we are drawing the radii which would be perpendicular to the side of the triangle in all the 3 cases, and also we are joining the center to each of the vertices so that the triangle is divided into 3 different triangles. Now the given triangle is now divided into 3 smaller triangles. Now triangle 1, the base is 15 and the altitude is a radius. So base 15, altitude radius, area would be given by half into 15 to r, half into base into altitude. Triangle 2, the base is 20 and the altitude is r, radius. So area would be given by half into 20 into r. And for the third triangle, the base is 25 and the altitude is r. So the area would be given by half into 25 into r. Alright, each of them take as the base for each of these three smaller triangles, and the altitude in each case is the radius or r. So half into 15 into r, half into 20 into r, and half into 25 into r. And when you add all this, the total area of the triangle, which should be equal to 150, is half into 15 plus 20 plus 25 into radius. Now half into 15 plus 20 plus 25, there is a semi-perimeter, right? Half of the sum of the sides, that would be semi-perimeter. So we get a radius into semi-perimeter. The total area of the triangle is equal to radius into semi-perimeter, and this should be equal to the area of the triangle 150. So area of the triangle is 150, semi-perimeter 30, and we got the total area adding the areas of the three triangles, base into altitude, altitude being the radius, as r into s, radius into semi-perimeter. Now semi-perimeter is 30. So a equal to r into s, so r equal to a by s. This was the formula we used. Radius of the inscribed circle in radius equal to area of the triangle divided by semi-perimeter. The formula we used in the first method. We have also derived the formula. In radius is equal to area by semi-perimeter, that is 150 by 30 or 5 units. R equal to a by s. The formula we have derived. This formula we used in the first method. Now we are deriving the formula. R in radius equal to area by semi-perimeter a by s, 150 by 30, 5 units. So the required in radius is 5 units. In radius 5 units. So that was math challenge. We bring you interesting problems for school exams, Olympiads, university entrance tests, competitive exams, and all numerical and aptitude tests. Subscribe to the channel, share and like our videos, and remember all our services are entirely free of charge for students all over the world. So students from anywhere in the world can contact us with their problem, and also remember we have once a week free online class for students all over the world. So any student from anywhere in the world can contact us. We shall meet again. Till then, thank you and goodbye.